Welcome to the Industrial IoT Spotlight, your number one spot for insight from industrial IoT thought leaders who are transforming businesses today. With your host, Eric Walenza.
Welcome back to the Industrial IoT Spotlight podcast. I'm your host, Eric Walenza, CEO of IoT One, the consultancy that specializes in supporting digital transformation of operations and businesses in Asia. Our guest today is Vincent Konstanje, CEO of Kigen. Kigen was founded by Arm and focuses on developing the new on-chip form factor called iSIM as the basis of connected device secure identity. In this talk, we discuss the role of the eSIM and of the new iSIM in establishing a certificate-based security chain from production through the entire device lifecycle. We also explored how iSIM can enable smaller form factors, reduce cost, and improve battery life on IoT devices by consolidating functionality onto fewer chips. If you find these conversations valuable, please leave us a comment and a 5-star review. And if you'd like to share your company's story or recommend a speaker, please email us at team@iot1.com. Finally, if you have a business challenge and would like to discuss solutions with me, please email me directly at erik.walenza@iot1.com. Thank you. Vincent, thank you so much for joining us today.
Thank you, Eric, and thank you for having me.
So, Vincent, really interested in learning what Kigen is doing, but before we jump into the company, I'm actually really also curious on your background and how you ended up as the CEO of this, I guess we could call it a corporate startup or internal startup. I know you've been with Arm for, on LinkedIn it says 22 years and 1 month, so for quite some time. It looks like Arm is quite a significant part of your career, but you were in some work previously. When did you first touch the IoT, or maybe your career started a bit before IoT was a term, but where did you first touch this domain?
Yeah, thank you. So, Arm quite a long time. I started as a software engineer at Arm, actually in our compiler team. And over my career, I moved after that into more commercial roles. I headed up our software and systems marketing group for a long time. And probably about 6 years ago, I started also heading up our security initiative. At the same time, about 4 years ago, Arm was bought by SoftBank, and security became a really important part of our offering, and particularly around IoT. So we started investigating more and more kind of what should we be doing in IoT for security. And actually we came up with something called Security Enclave, where you centralize some of your security thinking into your chip. And this is kind of something really useful for IoT. So as we were doing that, and as we were getting investment from SoftBank, I started heading up this initiative around how do we do better security in IoT. And that led me to now start forming a group inside Arm. And that group has now been spun out under the name Kigen. So that has been keeping me busy for the last 6 years, I think. And now we're kind of really accelerating by our offering being standalone and being spun out of Arm into the market as a standalone company.
Interesting. And if we look at the IoT market, where do you see security today? I was just chatting with a friend earlier this week who's running the new security division for TÜV-SÜD, which is approaching this from a regulatory and testing perspective. But for them, this has been kind of a boom year. Obviously, there's a lot of press behind that around the hacks and so forth. But we were discussing this is an ongoing battle, right? So there's obviously incentives on the other side to improve their capabilities in terms of compromising systems. But where do you see us today in the IoT domain? Do you see us moving towards a position of greater security, or do you see us moving towards a position of at least in the short term, of less security of systems?
So I think now, if you look in the last 5 years, our thinking is that IoT was quite confused. There are many standards and many ways of protecting the system, and which is not really helpful, because now if you think about these systems, it just needs to be trusted. And one of the things that we were thinking about, and actually are taking inspiration from, is kind of the security of your smartphone. Your smartphone is something you use for banking. Your smartphone is something you use for your social media. So it's kind of highly desirable to be hacked, but also highly defended. And the defense is more around kind of how do you make sure that your identity is protected, and how do we roll this out? So our mission is very much about how do we make security more designed in, easier, trusted, And the thing we came up with is kind of to extend something, kind of the SIM. And I'm sure you're familiar with the SIM in your mobile phone. Actually, you can use that same bit of hardware into an IoT space, and it becomes kind of very easy because the standards are there, the trust is there. It's just kind of, we need to extend it a little bit. We need to make it, and a couple of, and we can talk about it in more detail, but there are a couple of things we need to do to it. But generally, kind of, you build on that same basis. And once you start doing that, actually, the IoT security does, all boats get raised up higher, and we start to be able to trust it much more. Because at the moment, I think it is a bit patchy, to be candid. And it is patchy because there are so many competing standards and so many different ways of doing things, and isn't now quite clear on what the right way is. So that's very much what we are advocating, is take that now really high standard on the cellular security and roll it out wider into the whole IoT space.
And for Kigen, cellular security, is this orient primarily around IoT devices, or do you also address the traditional mobile phone?
So we mainly look at IoT devices. So what we do is we take some of the technology developed for the mobile phones and then adapt that for IoT. The mobile phones obviously have different characteristics than the IoT device. Maybe they have a bigger battery, maybe they're a bigger form factor. So how can we get that form factor down? But also they tend to have a higher cost of ownership, or they're a much higher cost device. So how can we get that down into an IoT footprint? So that's kind of really, we're focused heavily on IoT, but using technology from every space we can. And this is one of the spaces we are using our inspiration for.
I'd love to get into the value proposition, but before we do that, if we can just define a few terms. So I'm looking at your homepage here, and we have this frontline sentence: empowering solutions that scale trust and security through our SIM, eSIM, iSIM, and remote SIM provisioning technologies. So without getting too technical, can you give us the 101 on what is the difference between SIM, eSIM, iSIM, and remote SIM?
Absolutely. So now, obviously, everybody knows that SIM, right? So if you have your mobile phone, you have a SIM. If you want to change operator, you take a little bit of plastic with a chip out and you put a new one in. That is a SIM. The SIM itself is highly protected, highly secure, because clearly a lot of data depends on that, be that your banking app or your network access, your roaming in a foreign country. So it's really important and well-tested technology. But if you look at an IoT device, a SIM isn't perfect. And one of the things that isn't perfect on a SIM is actually the hole in the side. So having a hole in the side of the device now is maybe inconvenient from a design point of view for the mobile, but actually from an IoT device, if you're in a hostile environment, if you're in a dusty environment, if you're in a wet environment, you don't want a hole in the side. So the industry came up with a solution, which is called eSIM, where you don't no longer insert the bit of hardware, you just put it on the motherboard, on the main device PCB or board of the device, where the other chips are, and you just solder it down. Now, this is great because now you can close the hole and you no longer have the intrusion of dust and maybe moisture. But obviously, if you want to change operator, you now can no longer change the chip. So to do this, you have something called remote SIM provisioning, and you connect that eSIM to this remote SIM provisioning server, which is a very highly secure server, and it does a software operation onto your eSIM, which allows you to switch between operators, be that now Sprint and Verizon, or be that a Vodafone and Deutsche Telekom, or a Singtel and a SoftBank. You can make that switch remotely. So this is remote SIM provisioning. iSIM, we go one step further. If you put the SIM on the motherboard, you can also integrate this SIM inside another chip. This is like an SoC, a system on chip. And the advantage there is that you cut power usage, because you no longer need to power the SIM by itself, but also it becomes more secure and becomes a lot smaller. So this is kind of what we are doing and have been innovating from ARM's point of view, is creating enough building blocks to allow that SIM to be integrated into, say, a radio chip. That really brings a lot of benefits, and we can talk about it later on the podcast if you want. So is it clear enough? Is that simple enough?
That's clear. Just to understand, it sounds like the iSIM is superior from the perspective of cost, form factor, energy consumption. Would it be the case where you would be using an iSIM when you have higher volumes, let's say automotive OEM that's planning millions of units, and an eSIM for, let's say, a construction equipment OEM that has maybe 1,000 units going out and needs something that's, let's say, not investing the time to integrate this? Or what would be the reasons why you would use an eSIM as opposed to an iSIM?
So I think the eSIM technology is a little older. So eSIM technology is more established. iSIM is just about coming out. First iSIM manufacturer, which is Sony Semiconductors, used to be called Altair. And they've just come out with their chip about 6-7 months ago. As the first iSIM, we believe that by the end of this year, we'll have 2 or 3 more manufacturers of iSIM. But eSIM is there today. There are probably fundamentally 5, 6, 7 semiconductor makers that create the chip, and then many different SIM makers that can give you eSIM. So today it's very much about what is available in the market. Over time, we believe that an iSIM is probably about half the cost, so significant cost benefit. It obviously needs to be integrated into the radio, and that will take a little bit of time. But once that's there, I don't think that there's a lot of benefits of still using a standalone eSIM. There might be some benefits. An eSIM could be a different security standard or a different robustness. There is some choice. You can do the value versus the proposition point of view. But I think over time, we believe that iSIM will displace, eSIM will displace SIM, and iSIM will displace eSIM. Over time, it's just what's coming, and when different things are coming to market.
Okay, great, clear. And how does Kigen fit into this? So are you designing the hardware specifications and then having a partner to manufacture, or are you focused on the software and building the provisioning software on top of hardware that partners are manufacturing? Where's your place in the value?
As we were a part of ARM did some hardware IP, which effectively is a security chip inside another chip, right? So we call it a secure enclave. This is the hardware IP. ARM offers this to their customers. Other competitors of ARM offers this to customers. And what Kigen does is 2 things. We are doing the OS, which is the SIM OS, which effectively is the layer of software on top of that hardware block, as well as the secure server. The server we talked about, remote SIM provisioning, because they go very closely hand in hand. And then we work with our radio partners, main chip makers, on also provisioning those chips, because as a chip comes out of the factory, you have to insert some initial secrets, some initial keys, and which we are working with our customers to also make sure that happens. So the 3 parts are the OS, the initial keys, and then the management of this secure solution over time, which in our case is all software.
Share with us a bit about the differentiation, because let's say from the consumer perspective, this is all hidden in the back end. So it's not the functionality that they'll be interacting with, but I assume it's to some extent also highly differentiated, even if that's hidden from the end consumer. What are the key points where one solution might be superior to another point? What are the variables that you're competing on here?
So I think now, if you look at Kigen itself, we probably have a head start of about 18 months on our competitors. But the key thing for us is about the iSIM. We believe that iSIM is so much better than eSIM or SIM, as well as being a fantastic standard for IoT security, that we believe there's now a great benefit. And some of the benefits are now very obvious. iSIM has 1 less chip. So you go from 3 chips in a design to 2 chips, which is really, and maybe if you go further in the integration, you could go to 1 chip, which is a form factor size advantage. And to me, it's very much now think about when Apple introduced the iPod, they took the mini disc, which is just coming out, and actually that form factor allowed them to do a completely different device, right? The MP3 player that iPod was is a completely different device than anything beforehand. So again, when you think about form factor, going from 3 chips to maybe 1 chip can really start driving different devices. And we can talk about it in a second. Secondly, is the power usage. We believe that's now the standby power, which is really important. Is a device does nothing, but for a long time, it's now 70 to 80% better in an iSIM over a classic SIM. And then the cost, again, also about halves from an eSIM to an iSIM, which makes it much more scalable for IoT, because IoT is really important to make sure that we can reach many devices at a much lower cost point than you maybe do with a mobile phone. So those 3 main benefits are, I think, really going to drive, because if you think about low power, that means that you can have a device maybe on the battery for 10 years. Really important what the standby time is. It's really important for the device when it's off, that do not use too much power, because otherwise it drains the battery. Again, the size gives you smaller devices, which is really important. And clearly now the cost gives you higher volume, gives you also into devices you maybe previously didn't think about cellular. Now you can start using cellular connectivity and these kind of levels of security.
Got you. No, that's an interesting point. I suppose if you're talking about an automobile, maybe a little bit less price sensitive and willing to pay for energy consumption is also not a significant issue there. But if you're talking about a lot of IoT devices that might be in the field, then the form factor is critical. The battery life is critical. Cost per unit is critical if you're putting tens or hundreds of thousands of units out. Just a quick diversion here, but is 5G relevant here? Because I suppose connectivity for these smaller devices, which have very constrained battery capacity, people might be looking towards a LoRa or a Sigfox, some kind of LP one, whereas cellular might not be historically a priority option there. For the iSIM, would you be looking at more of like a 3G connection, or would you be looking at, a 5G connection? I know 5G has a standard that's also designed for to maintain battery life. What would be the preferred cellular option with an iSIM?
I'm not sure if there's actually a preferred cellular option, right? It depends on the use case. Right now, you have to go, what kind of use cases are you talking about? If you're talking about now an IoT device that has a very long battery life, it's only communicating a few bytes every month, then clearly, using something really lightweight, some of the Cat-M standards around 4G and 5G are probably really useful for that. Compared to LoRa, I think the benefit of the cellular standards is that I'm sure quite well understood, but it's around the world, right? It's easy to kind of manufacture once and deploy everywhere. Because I think that is also some of the things that IoT is a worldwide supply chain problem. How do we manufacture something in one country and deploy it in the other country? But going back to your cellular standards, and the other thing it could be you could use a 2G modem because it's cheap, it's available. On the other hand, 2Gs might get switched off. And I was talking to a robot maker. They were doing cleaning robots. And actually, they have a lot of analysis they do. They don't have to worry about the big battery because they're cleaning anyway. And actually, they're doing massive amount of data. So the more data you can get, the better. So they were looking at high-end 5G modems. And again, there can be benefits there from an overall cost. So there can be benefits there from a form factor of how much space they have to fit these things in. So from an iSIM point of view, it's very much driven by the use case and the additional things we can make available, which sometimes might be a really low bandwidth modem, which kind of takes a little bit of energy, versus the more higher bandwidth modems.
Okay, great, thank you. Let's dig a little bit more into the technology here. Maybe just as a starting point, is this technology maturing at the pace of software or hardware? So what is the pace of change around this technology? What do the development cycles look like for you?
It starts with hardware. Initially, you need to have that secure enclave, the security area on the chip, which is coming now, right? We have, hence why my answer is we started about 6 years ago in ARM. So it's taken a bit of time to get it into the hardware. But once it's into the hardware, it becomes a software pace. Because once you have that really secure area, you can update it with a server. It becomes a software update. It becomes a SaaS model. You can actually, the iSIM itself does initially it does security for the network, get onto the network. But because the iSIM is so deeply integrated into the main system, it allows to do other things as well, right? It can do security for the whole system. And again, from that point of view, you can start adding features and security domains to the iSIM, which allows you to do things like connection to the cloud, automatic enrollment by putting some of the cloud certificates on the iSIM, things like whole device security by being something called a root of trust, which means that the iSIM signs any software that arrives onto the device and makes sure that the software comes from a credible source. And you can do more and more based upon that really secure corner of your design. So initially it starts with hardware cycles, but once it's done, actually it doesn't need much of updating. It doesn't need to be evolved much. We can just start developing a software stack on top of it.
Interesting. So to some extent, the nature of the SIM evolves or becomes a bit more complex in terms of the functionality that it provides. So you mentioned the extending security into different areas of the device and also cloud connectivity. Would you foresee, if we look forward 3 years, 5 years, 10 years, additional functionality kind of accruing on the iSIM, or is there some significant constraints around what type of functionality could be reasonable or from just a kind of a trade-off perspective on the iSIM versus through other software embedded on the device?
Yeah, so iSIM is very specialized on security, right? So it is see it as your crypto safe on your chip, and the ability to manage that and use that crypto safe. So I think the functionality of the iSIM is very much around what security services can we do, and the initial security services around getting onto the network. Right? That's the SIM standard, but actually the SIM standard is a Java OS standard. And if you really think back 20 years ago, I'm not sure how old you are, but when the mobile phone came out, SIM was really trying to make a play for things like your address book and even games on the SIM. So that fundamental technology is there and has been there for a long time. The trouble with SIM is it never really took off because the SIM in that little mechanical tray on the side of your phone, that tray actually limits it a lot because the power usage of the tray is quite high. The speed of the tray is quite slow because of electrical connectivity. And once you go to iSIM and you integrate it into the main SIM, that all disappears. And actually now the functionality gets unleashed in our eyes, but very strongly focused on that now crypto security services. You want to keep that small. You want to make sure that that there's not too much going on, because if you have to get a bigger and bigger system, that would not be good from a security point of view. So you want to really keep it on the where do I keep my digital keys? Be that digital keys for your network, or digital keys for your onboarding onto the cloud, or digital keys for the rest of your system. So it's very much like a key management system onto your chip, but highly defended, highly secure, and also managed by a remote server.
Clear. So it sounds like then a fairly horizontal solution in that the functionality it provides is going to be needed to some degree by every device, not a lot of specialized kind of vertical or use case oriented functionality. But you mentioned earlier that integration is necessary to some extent. What does that integration look like? Is it integration around a particular asset class, or is it specific to the model? Is it each OEM that wants to put out a new product is going to then devote some resources towards customizing the solution for that particular model?
So the integration is the integration into the other chips. But then the question is, how do you use it? It is a crypto safe on the side of your device, and you can use it to store many secrets. And I think that is where the OEMs can differentiate or actually use this technology differently, because one will put secrets on how to go enroll into their clouds. Someone will put secrets on how to roll into any cloud. Others will put secrets on how do I make sure my software is well managed, highly secure, updatable. So there's many different things you can use that crypto safe for. And I think that is where once you have that common plumbing inside every IoT device, it becomes a really kind of well understood way of working with the IoT device. It then allows the OEMs to use that that horizontal technology to start specializing vertically. Does that make sense? Maybe it'd be nice to start talking a bit about use cases, because that can also bring it a bit more to life.
Yeah, that'd be great if you can walk us through one.
One is very public, so we like to talk about that, and some of them are still in development, so they're obviously a little bit more careful on the details. But now one of the public ones is a smart tracker. This is developed by Sony. The smart tracker is a very interesting, innovative design. It is a circuit printed on plastic, so it's effectively a device which is completely made out of plastic, which is battery. Circuitry is all printed on plastic, and the only one thing is they need one bit of silicon, one chip. So they have one chip on that device. This is a smart label. It's a cellular connected smart label. You can put on the side of us maybe a shipment container or some high valuable commodity. Say, think maybe a vaccine storage container. It can keep an eye on where the device is, so where the container is, if it's opened, if the sensors give you the right information. Because it's all printed plastic, right? It's really important to not have too many components that aren't plastic. The one component you can't get away with is the main chip. And again, if you integrate the SIM into that, the radio into that, then actually it becomes a really interesting use case on how to start tracking high value products around the world. If it gets in higher and higher volume, then clearly prices will come down, and you can start pushing this into other areas too.
Gotcha. Maybe you can let me know if this is an interesting question or not, but the open seas remain a bit of a challenging area for tracking, but also a critical area because so many goods move through them and could potentially be damaged or have some degradation along the way. There's been a lot of press recently around different satellite networks. Is iSIM also capable of communicating to satellites? I'm just not an expert here. Maybe this is something that I should know, but how does satellite fit into the connectivity solution here?
Well, that's more satellite is more about the radio. The radio has certain capabilities. So if you wanted to communicate to a satellite, you would have to use a satellite radio. Now, I'm not an expert on satellite radios and their security. There's no reason they couldn't use similar technology as SIM, because again, you need to have an initial key. You need to identify who you are. Clearly, now satellite communication is more difficult. It's more power hungry, so that might not be a perfect use case for tracking things around the sea. Now, not impossible. I think it's more that you track the boat, probably not the individual container by satellite. But if you look at what happened on the open seas, and is my vaccine exposed to a power outage, or the vaccine needs to be cooled to a certain amount? Has it been cooled all that time, or a different has seawater come into my container, or has my container been shaken? Those things can be hooked up to smart trackers, and the smart tracker can then analyze this. Not in real time, but maybe when they arrive in a port, say they arrive in Rotterdam, they can connect to the cellular network. They can give a status of what's happened to my container, what's happened to my product. Has it been inside the specifications, or has maybe something gone wrong? So you can do that maybe not real time, but when you come into a different port. Using cellular technology has the advantage there that it doesn't matter where in the world you arrive, you'll still be able to communicate. And you don't have to put any special infrastructure in place. You can just use the cellular networks that are available there.
Okay, so you report the data when you arrive back at the port. The market that you've been in the recent years, have you seen any shift in terms of how decisions are being made around what solution is used in terms of the hardware and also the software? Or is it the same basic group of stakeholders going through the same design process that it has been for the past 10, 20 years? Have you seen a shift in terms of who your customer is within the organization and how they evaluate solutions?
I think we have. If you're talking about 20 years, so that's probably quite a long time. I think we have seen a massive movement around the maker movement, which I found really interesting. Small companies innovating, and we think this is really important. So this is what we are now, why we are trying to standardize security for IoT onto iSIM, because actually we believe that a lot of the innovation is going to come from smaller companies, from agile startups that are finding new ways of solving problems. I'm sure that that over time it will also get then developed by larger companies, but and unleashing that innovation and that network of innovation is really important. However, today, I feel as a consumer that I trust large brands, especially on my security, and that's good. It's good for one sense, that I can rely on a brand to update my mobile phone, maybe. But when it comes to IoT, there are so much different solutions need to come to the table that we need to make sure that everybody has access to good technology and everybody has access to technology we trust. And security obviously is the basis of that. So that's why we think that the SIM technology is really good, because people understand it. I don't have to explain too much about why it's good, because people now realize that this is what they use for banking. And if we can now make the whole of IoT start using that kind of foundation, it becomes much easier, and we get more innovative companies coming to market with products we can trust and products we're happy to put on our network, products we're happy to start using. I think that is really important to unleash that wide community of innovators.
Excellent point. To what extent is the eSIM and then going forward the iSIM standardized across solution providers and telcos? Is there a set of widely adhered to standards, or is this still somewhat in flux?
So the eSIM has been standardized for quite a while now. The GSMA, which is the mobile operator consortium, which is now extended to an industry consortium, has been standardizing that for the last maybe 8-9 years. And then now they're coming to market, and they have been coming to market for the last 5 years, I think. iSIM has just been approved by the standard. So iSIM is effectively a form factor change on eSIM. So the integration into the main chip. So from that point of view, it's very similar to the eSIM. The standard is ready to go, and you are seeing in the market more and more people coming out with completely standard compliant products. Some of these things are on their way to standards. Some of the things that the standard is demanding very high security levels, and some of these things we have to build the technology to actually reach those security levels. But even that's happening, and the security standard is getting more and more adhered to, which allows that interplay in the industry. Now, we're not completely there yet, but we are now very close to having many different parts work together, partly driven by the mobile phone companies. They are now rolling eSIM out into their products. That's going to be accepted around the world. That allows us to then push that same technology in that smaller iSIM form factor into IoT and start using that as a standard, which is really nice. And that allows you that plug and play. I create something in, say, Taiwan, and I export it to Germany or to Canada. And I know I don't have to have a separate SKU. I can just do a software update with my secure server and make sure that I have the best connectivity, the best profile in country that my device requires.
Yeah, no, that's an interesting use case. I know there's a few providers out there of global SIMs for roaming for devices that might, let's say a healthcare device or something that might be embedded and need to connect around the world. And I believe my understanding is those are often SIMs that are connected to a plan that has coverage in 200 countries. The eSIM then would be a substitute for that, as I understand. Is it possible to do basically automatic provisioning? So you show up in the airport and immediately your device connects to the applicable network, or how would that actually look in practice?
Yeah, so it depends a little bit if, we have to move a little bit away from the consumer thinking, right? So in the consumer thinking, you would arrive with your mobile phone into a different country, and it will offer you these are the three options you have for data connectivity. Feel free to kind of select something. If you're M2M, if you're a machine-to-machine communication or IoT device, you probably want to do that. Your company wants to decide that. You arrive in the port of Rotterdam, and you have a plan which is suitable for Rotterdam. Right, so you have the server can update and make a local profiles. Instead of using roaming, you can use local profiles, which is better price. But actually, some countries it's actually mandatory; they're not allowed to roam for more than a month or like a holiday time. You're not allowed to be permanent into a country and still roam. But also, if you look at the manufacturing, right? If I create a chip module and a module into the device, all right, the modules are like a radio module. Put it into a device. It can be many different devices and can be owned by many different companies. But some of that, connectivity needs to be built in from the start. Security needs to be built in from the start. So how do you make sure that even though the security is built in from the start, it's still you can easily adjust it to the use case and to the company that eventually owns this product. And again, this is where eSIM and iSIM come in with their remote SIM provisioning. That supports that whole supply chain of creating a chip, putting it onto a module with its radio, putting the module into a device, and then device into a use case. I think that's very important. Kind of how do we go through that whole supply chain and make that the industry work together?
Okay, yeah, great. It seems to be a pain point that's very much worth addressing right now. I think the example that you gave us before, if I'm correct, that was an eSIM example. I know iSIM is just kind of coming to market now. Do you have an example of an iSIM deployment that you'd be able to share with us and walk us through?
So no, that's example about the smart tracker was an iSIM example. Yeah, because the key thing there was they wanted one chip, and the one chip needed to do the radio, the one chip needed to do the application, and the one chip needed to do the security. So that was an iSIM integrated example, which is now in production and is something that actually we're really trialing in the field today. But other examples, right, is we are working with a water meter manufacturer. Water meters are now is very useful if they can communicate. You don't have to go around to water meters to all measure them. But water meters clearly don't always have an electricity supply, so it's very much about battery. And having significantly lower standby power is really important. So iSIM is really useful there. Another project we're working on at the moment is like medical trackers. Medical trackers is like a smart watch, but then with more medical data. Again, battery life really important, but also form factor. Smaller is better. You don't want a big clump on your wrist or maybe on your arm. That's very useful. And then, and last but not least, we're also doing in industrial. I know you're quite interested in that. Chemical metering inside really hostile environments, keeping an eye on the chemical processes. Again, this is something where it's really useful to be able to deploy many sensors in many different places. And again, there's battery life considerations, but also size considerations, where iSIM is really playing a good enabler of these use cases.
Good. So it sounds like this is in production now. Does that mean that if a company is interested in using iSIM, that they're basically able to open it to purchase it on the open market, or is it more of a still kind of let's say a strategic pilot that they would be deploying for the next several months?
Yeah, still a strategic pilot. So we're really looking at what are the use cases we initially really want this. We are working with Sony Semiconductors and Murata as a module maker. And I'm sure that once it becomes generally available, they will make a lot of noise about this. But it is real, and we have quite a lot of things in the media. We're talking about it, and we're demonstrating some of the solutions they have. And then obviously, we're working on some of those large examples to take that same technology and roll it out into those use cases as well.
Okay, interesting. Do you have a rough timeline? Would we say end of 2021, mid 2022, when this might be something that you can buy more off the shelf?
Yeah, so towards the end of this year, 21, I think you'll see more and more solutions. We know that another 2 chip makers are coming to the market this year. Now that then goes into the module makers. The chip makers with the radio gets put on a module. Those module makers should be appearing towards the end of the year, early next year. So I think 2022 is when you'll see the real ramp. So when you actually have multiple modules with multiple suppliers offering you multiple different features. This is kind of in the next 6 months, we are kind of really excited that this is about to take off.
Vincent, I think we've covered a fair bit of territory here. Is there anything that we didn't touch on that is kind of critical for listeners to understand?
No, I don't think so. I think we went really nicely around the houses. I think to me, it is the key thing is now, how do you enable trust in IoT devices? And I think this using the SIM technology, it is well standardized. It is used by many different companies around the world. So there's lots of different suppliers, but also kind of integrating it into iSIM actually gives you that ability to push it further and wider. I think is really important. If people are interested, I'm more than happy to reach out to me directly. I'm available on LinkedIn. We're doing a lot of publication. We would happily talk to anybody and see how we can adapt to their use case, or how we can put them in touch with the people that are maybe currently under NDA, doing lots of innovation around this and enabling these new use cases into the market. Feels really exciting to me. Now, we've been talking and working on IoT for the last 10, 15 years, and we're seeing more and more use cases coming to market now. So it really feels like we're starting that upwards hockey stick when it comes to different things on how to make our lives better, how to make the world better and a more efficient place. So we are really excited about that.
Oh, absolutely. I mean, these are the critical improvements that make IoT something that's not just interesting, but that's to some extent easy and affordable, right? And that's where we need to go now to see real impact. Just for the listeners, the website here is kigen.com. And as Vincent mentioned, you're welcome to reach out to him directly on LinkedIn. Vincent, thank you for taking the time to walk us through this today.
Yeah, fantastic. Well, Eric, thank you very much for your interest and your very interesting questions.
Thanks for tuning into another edition of the IoT Spotlight podcast. If you find these conversations valuable, please leave us a comment and a 5-star review. And if you'd like to share your company's story or recommend a speaker, please email us at team@iot1.com. Finally, if you have an IoT research, strategy, or training initiative that you would like to discuss, you can email me directly at erik.walenza@iot1.com. Thank you.